My name is Ross Bagtzoglou. I'm also known as Dr. B. I'm originally from Greece. I came to the United States in 1985 as a Fulbright scholar. In the department, I'm a full professor. I used to be the department head. I joke with my students, I model for a living. I apply mathematical techniques, numerical methods and numerical models to study environmentally relevant phenomena. At this point, I have 3 projects that I'm actively involved. The first one is funded by Eversource Energy. It deals with resilience of the grid, particularly how infrastructure, utility poles behave under extreme weather scenarios, winds and other phenomena. The second project is the PIRE, the NSF PIRE. That is a huge project. The contributions we are doing from engineering deal with application of forecast models for drought or wet seasons, with always the emphasis on contributing towards the food security of Ethiopia and particularly the Blue Nile. The third and final project is a collaboration with the United States Geological Survey and deals with hydrogeophysics and how we can apply geophysical techniques to study processes in the hyporheic zone.
In USGS, we were trying to investigate the dynamics of less mobile zones in porous media, and specifically hyporheic zone. Hyporheic zone is very important in contaminant transport, and it might be also important in greenhouse gas production. Also, I had the opportunity to collaborate with other groups and investigate the effect of chaotic mixing on the efficiency of biogas production. And also we were using numerical models to investigate the performance of flow sensors.
I derive tremendous pleasure to apply mathematical techniques to make predictions about environmentally relevant processes. How does this affect everybody or many different people in everybody's life? I can give a very simple example. At UConn, part of the water we all get comes from the Fenton River. Back in 2005, I believe, 2004, I was part of a team that did an extensive study of the Fenton River to make sure that we don't have any droughts on campus. Sometime, usually around October, you start getting some notifications about voluntary conservation measures. All these triggering points of where these warnings come, voluntary or involuntary, have been designed and analyzed by the team that worked on the Fenton River project back in 2004. And my model, groundwater model predictions, actually informed those decisions. So yes, what we do is theoretical in some cases, but it's very, very practical and affects people's life on a day-to-day basis.